Okay, so I downloaded my file and I discovered I hadn't changed the title cover, so I had to make some adjustments on the fly here. So we're talking about section 6.4, special parallelograms. We want you to learn to use the properties of diagonals, rhombuses, and rectangles, okay? Diagonals of, that should say of rhombuses and rectangles. The student should also learn to determine whether a parallelogram is a rhombus or a rectangle. And I also want you to know that a square is a special type of a rhombus and a rectangle. So we are going to be dealing with these three areas of our foldable, and you can take the notes on the appropriate section of those as you go through the video. Okay, so what we are dealing with today, zooming in on this, we're going to be dealing with a rhombus, a square, and a rectangle. Okay, so we want you to know that rhombuses are parallelograms where all sides are congruent. Okay, and rectangles are parallelograms where all the angles are congruent, which means they're 90 degrees. Okay, so a square has both of these, all sides congruent and all angles congruent. Okay, so it's the most restrictive form of a parallelogram or even a quadrilateral. So we've seen this slide before, but I want you to add these definitions if you haven't before. Add them to the appropriate pages. So for the rhombus page, add the definition that a rhombus is a parallelogram with four congruent sides. To the rectangle page, add that a rectangle is a parallelogram with four right angles. And then finally to the square page, you need to add that a parallelogram is a square is a parallelogram with four congruent sides and four right angles. Okay, that means it's a rectangle with all congruent sides or a rhombus with four 90-degree angles. So let's go back to our rhombus page and add some theorems about rhombuses. Theorem 6.9 says each diagonal of a rhombus bisects two angles of the rhombus. Now let's take a look at what this is going to look like. So we have a diagonal, we have a rhombus, we have a diagonal here, and we're going to say it bisects two angles of the rhombus. Okay? So what that ends up doing is it creates two isosceles triangles, which makes it really easy to deal with if we're trying to find angles and things like that based on what we've just learned in Chapter 4. Now, Theorem 6.10 goes one step further and says the diagonals of a rhombus are perpendicular to each other. Okay, so this is kind of neat, and we'll be able to use this property to find missing side lengths or lengths of diagonals and things like that. Okay, so make sure to include these theorems along with these diagrams. More theorems involving rhombuses. Theorem 6.12, which is the converse of Theorem 6.9, says if the diagonal of one parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. Okay, so what this theorem is useful for is for showing that if you've got a parallelogram with a diagonal that bisects it, you know that that parallelogram is a rhombus. So we use this for proving that a parallelogram is a rhombus. Notice that you first have to know that your figure is at least a parallelogram before you can use this theorem. Theorem 6.13 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Now this is the converse of Theorem 6.10. So first again we have to have parallelogram with diagonals that are perpendicular. If we know all these three things, then we know that that parallelogram is a rhombus. So these two theorems we will use for proving that parallelograms are rhombuses. Okay, so now let's turn to your rectangle page of your foldable and take some notes on theorems involving rectangles. Theorem 6.11 says the diagonals of a rectangle are congruent. Okay, so that means that the length of one diagonal is the same as the length of the other diagonal. Okay, and Theorem 6.14 says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if you have a parallelogram with two congruent diagonals, you know that parallelogram must be a rectangle. So here we have an example. We're given this parallelogram ABCD, and we want to know for what values of x must ABCD be a rectangle. Oh, and you know what I meant to do is I meant to make, yay me, I meant to make this, and this, and say, ooh, that's that side length, or that diagonal length, and ooh, that's that diagonal length. Okay, so hopefully, sorry about my messy thing, I just realized it hadn't finished that properly. Okay, so we want our diagonals to be congruent, right, in order to ensure this parallelogram is a rectangle. So we need 3x minus 9, that diagonal length, to equal 4x plus 7, right? So if we subtract 3x from both sides and subtract 7 from both sides, we get x is equal to negative 16. So that's the value of x for which ABCD must be a rectangle. Okay? Now let's turn to the square page of your foldable, and we'll talk about squares. Squares are the most restrictive type of parallelogram. We need to have several things happen before we can declare something a square. First of all sides have to be congruent. You have to have two sets of parallel sides. All angles have to be equal to 90 degrees, and the diagonals have to be congruent and perpendicular. On the opposite side of this, if you know you have a square, you know all these things are true. Okay, and so you can use that to help solve problems. So, squares possess all the properties of both the rhombus and the rectangle. And since they're a special case of both the rhombus and the rectangle, all the theorems that apply to either the rhombus or the rectangle apply to the square as well. So we can use these formulas, or these theorems, to help solve problems that deal with squares. So what we've learned, parallelograms have several theorems related to them that apply to rhombuses, rectangles, and squares. And using these theorems and their converses, we can identify properties of shapes and allow undetermined shapes to be identified from their properties. So we can do a lot with these. That's it for now.